Hello, so today we are doing weekly contest of Leetcode, weekly contest 161, and one of the problems is this medium problem called count number of nice subarrays. And so the problem says that we get an array of integers, nums, and an integer k, and we wanna, and the definition of a subarray, we call it nice if there are k odd numbers on it, and we get the number k as input, and want to return the number of nice subarrays with using this definition of nice subarray. So for example, here with this array, k equal to 3, so a subarray is nice if there are 3 odd numbers, and here the only 3 subarrays with 3 odd numbers are this one where you have 3 ones, and this one where you have 3 ones also in 3 odd numbers. Yes, this one and this one. So basically this one and this one. This one doesn't have any odd numbers, and so there is no subarray with 1 odd number, so we return 0. This one, there are 16. You can see there is this, there is, for example, k equal to 2, so there is this one, there is this one, there is this one, there is this one, and there is this one, and there is this one. You get the idea. There are a lot of them. So anytime you have the start and the end of the array that are different, we need to count it. So let's see how can we solve this problem. So these are the constraints, and now let's see how we can approach this problem. Okay, so let's see how we can solve the problem. This problem. So I think the first thing we should do is just take a look at some examples and see if we can get an intuition of what we need to do. So the first example was the array 1, 1, 2, 1, 1, and k was equal to 3, right? So if we look at this here, what we have is that k equal to 3, right? So we need 3 odd numbers. So this array definitely has 3 odd numbers, right? And this array also has 3 odd numbers, right? So does this tell us anything? Well, we know at least that we need to somehow count. We need to count the number of odd numbers in a range, right? Because here left is here and right is here, and here left is here or right is here in a range, some kind of range, left and right, right? Now let's take one of the other longer examples. So let's take this one, 2, 2, 2, 1, 2, 2, 1, and 2, 2, and k is equal to 2. So this is example 3. So if you look at this, you can see that we are looking for 2. So this one counts as one of the subarrays. Then we have this one, and then we have this one, and then we have this one containing the first element. And then we also have this one, because it has 2, and this one has 2, and this one has 2, right? Is there anything else that is missing here? Yep, so also this one, the one starting from here to here, and this range, and this range, you get the idea. There are a lot of them. This one and this one, so there are 16 overall, right? So you can see here, the count here is a lot. So basically, one thing that we know is that, so one thing you may have noticed here is that when we reached this one where we have 2 odd numbers, we not only counted just this one or just this one, right? We counted all those that had 0 odd numbers as a possible start of our subarray, but our ending has to be this. But all those before it that has 0 odd numbers had to be counted. And so one thing that may help us figure this out is what we want is to find out So basically what we want is for every position, so for every position I, we want to count the number of subarrays ending at that position, right? Ending at I, that have k-odd numbers, right? So basically we want to count, for this case, we want to count for each position I, we want to count the number of subarrays ending at that position that have 2 odd numbers, right? And so ending at I, but not necessarily starting at 0, right? So they may start at 1, they may start at 2, like this one here. And so to know how many odd numbers in a range, let's say left to right, like this, we will need, let's call this one, let's just give this one an abbreviation. Let's say number of odd numbers in a range, right? Let's call it this abbreviation, left to right. So in the same way as prefix sum, this here is just equal to, if I draw this like this, and let's say we are at a range where we have here left and here right and here 0. So to get the number of odd numbers here, it's just the number. If it was sum, it would be basically if it was prefix sum, right? Let's say the sum here was 8 and the sum here was 4, right? To get the sum here, we just do 8 minus 4, right? The same way with odd numbers, right? And so the kind of formula here is that the number of odd numbers in the range left right is equal to the number of odd numbers in the range 0 to R, right, in this entire range, minus the number of odd numbers in the range, actually, just to simplify this, let's just call this the f, function f. So the number of odd numbers in the range left to right, L to R, is the number of odd numbers from 0 to R minus the number of odd numbers from 0 to L minus 1, right? The same way with prefix sum. So these here we can keep counting the odd numbers. So with the for loop for all elements in the array, we can keep counting the odd numbers, right? We can keep a variable that just checks if the number is odd, counts it, so that with that we get at each position I, like which is the ending of the interval, we would have count odd as the number of odd numbers so far. And let's call this one x, right? And what we want exactly is to find the ranges that have k odd numbers. That's what we want. What we want is all ranges that have k odd numbers. So what we want is for this value here to be equal to k, right? Since this value is the number of odd numbers in a range, right? So overall, the formula that we are looking for here is, and we should check this only if the count of odd numbers is bigger or equal to k, because otherwise there is no there is no prefix of the subarray that will give us k here, because in order to have like k equal to some number minus a number here, you need this one to be bigger or equal to k, so that here can be only 0 or 1 or 2. You can't have a subarray with -1 odd numbers, right? So this one has to be bigger or equal to k. And so so what this means is what we are looking for here is what is the, we need to, when we reach bigger or equal to k, we need to find the number we need to find the number of previous positions that if we start from that position and end at I, we will get k odd numbers. If we start from it, we will get k odd numbers, right? And this basically here means that x is just count odd minus k, right? And so basically what this means is that when we are looking for, let's say, k equal to 3, right, and we are here at a position I, and let's say our count odd here is equal to 6, right, we want to find all the prefixes, right, all the elements in this prefix here that have what, 6 minus, okay, let's make this a little bit clear. So let's say k equal to 4, that have 2 odd numbers. And all these positions, if we start from them, we will have a range. So let's say here we have 2 odd numbers, 2 odd numbers, 2 odd numbers, but then here we start having 1 odd number, right? We want to count all these positions, all these subarrays, because all these subarrays will give us 4 odd numbers, right? And so this is so you can see here it's very similar to the prefix sum problem. And so what does this mean? So this means is that we need to keep track of the number of positions that have x odd numbers, right? And this basically will help us in a way where when we reach a position that has I, that has count of odd numbers bigger or equal to k, we can just say, okay, just give me all the positions that have this number of odd numbers, and all these positions my subarray can start from and end at I, and I could just add that to the result I'm looking for, right? I hope this is a little bit more clear. So the code for that would look something like this. So it would be really simple. We need a map, a prefix. So we need a couple of things, a couple of variables. So code. So the variables that we need are counting the odd numbers so far, right? So counting the odd numbers so far, which would start as 0, right? So this here would count the number of odd numbers. So let me just here put the variable definitions of odd numbers ending at I, from 0 to I, from 0 to the current position. So this is basically odd numbers so far in the entire array. So this what would allow us to get this here, f of 0 to r, right? And so, and then we need the prefix map, right? So prefix here, what would it be? So prefix would be the number. So prefix of I would be number of prefixes of the array, basically the number of subarrays starting at 0 and ending at some position of the array that have I numbers, that have I odd numbers. So this basically will allow us to just take prefix of count odd minus k, right? And so we have that map. Now we just go through the array. So for I in the range of the length of the array. And what we will do is we will say, okay, at this position we know that we have I add numbers, right? And so that would be what's so what I'm doing here, I will not consider the current position, right? So prefix I, number of prefixes of the array that have I add numbers, and so here that means that my prefix of count add, the number of add numbers so far increases by 1, right? So basically, if I have an array like this where you have 1, 1, and 2, so here, so basically I'm doing I minus 1, just for the, because arrays start at 0, but here at this position 0, so prefix at position 0, so at this position here, my prefix of 0 add numbers, so I have one array that has 0 add numbers before that position. Now when I go here, now I already have 1 add number here. So the prefixes just before that position that have 1 add numbers, that's just 1. That's this here. And then when I move to this position, I would have prefix at position. So prefix, the number of subarrays that have 2 add numbers, I would have this one, right? So that would be 2. So you get the idea. And so I will increase that, and then I will check if the current element is add. So that means equal to 1. In that case, I would increase the count of my add numbers so that the next time I can say that there is one more position that has, for example, 2 add numbers. So we'll increase this, so plus 1. And then when we reach, so as I said here, when we reach a count that is bigger or equal to k, that means I need to count all the previous subarray, all the previous starting position of the array ending at position I that may give me k add numbers. And so I would say if count of add is bigger or equal to k, then let's just keep a variable here of the result, right? So my result will need to increase by prefix of what? Of what I said here, count add minus k, the value x. So all the, when I'm at position I, and I have, let's say, k equal to 4, and currently I have 6 add numbers from 0 to I need to find all positions that have 2 add numbers in the left. Because if I go up until 1 add number here, I would have 5 add numbers and not 4. And so I need all those that have 2 add numbers, so the range from that position to I has just 4 add numbers. And so let's call these, so here, let's call that x. So my x is equal to count add minus k. And what x represents is just the possible starting position of subarray such that basically the number of possible starting position of the subarray that would make subarray ending at I have k add numbers. And so that would mean here my result would be plus prefix of x, right? So x is basically, for this case, x is value 2, and so I want all the numbers of subarrays that have 2 add numbers, because those are my starting position, and anything in between those starting position and I would have 4 add numbers. And that's pretty much all there is to it. At the end, I could just return the result. I hope this makes it a little bit, I hope this is clear, but the gist of it is that we will keep a prefix array or a map, whichever one you want, that at each position that would count, like for, let's say, it will say for one odd number there are 2 prefix array that have 1 odd numbers, or let's say 3 prefix array that have 2 odd numbers. And then what I would use that for is this formula here, where I'm looking for any range that has k odd numbers, and to find those ranges, each time my count odd becomes bigger or equal to k, I will search for all the possible starting position that will make a subrange that has k odd numbers. And the way to look for those is to look for all starting position that have x odd numbers, and x is just the difference between the count odd numbers so far and k, right? Because all those I can start from and have k odd numbers. And x may be 0, for example, if it's the entire array. And that's pretty much the gist of this algorithm. Maybe let's run it on an example just so that it becomes more clear. So if I take, let me take this example, 2, 5, 6, 9, and let's say k equal to 2. So the prefix array here would be, or the prefix map would be something like this. The number of subarray that have 0 odd numbers, that's just this one, right? So 1. The number of subarrays that have, so this is just this subarray. The number of subarray that have 1 odd numbers, those are just this one and this one, right? So those are 2, 5, because it has just 5 as an odd number, and 2, 5, 6. So that's two subarrays have 1 odd number. And the number of subarrays that have 2 odd numbers, those are 2, 5, 6, 9. Only that one, so just 1, right? And so if we were asked k equal to 2, what do we need to do? So we have the prefix here, and so our result will start only if, so we'll start adding to this only when count odd becomes bigger or equal to k, and that becomes the case here. So in the iteration where we are exploring this one, we would say res plus prefix of x, which is x is count odd, minus k. And so count odd at this point would be, we would have this one is odd, this one is odd, so that's 2, and k equal to 2. So that's 0. So we need prefix of 0. And so that will say just 1, right? And that's the case, right? We have only one subarray that has 1 odd number. If we take another example, which is, let's take, for example, this one that we have in the input, which is 1, 1, 2, 1, 1, and k equal to 3. So what would happen here is that the prefix array would be something like this. So the number of subarray that have 0 odd numbers, that's just nothing, the empty list, nothing, so 0. A number of subarrays that have 1 odd number, that's just number of prefix subarrays that have 1 odd number, that's 1, right? It's just this one. The number of subarrays that have 2 odd numbers, that's at this position here, we have 1 of them, right? And then when we reach this position, now we have another one. So that means here we have 2. And then when we reach this position, we have the number of prefix subarrays that have 3 odd numbers. That's 1, 1, 2, 1. So this one has 3 odd numbers. And then now here also we have another one that has, and then when we reach, so here it has 3 odd numbers that's equal, bigger or equal to 3, to k, right? So now we need to add to our result the prefix of x, what is that in this case? So prefix of x is just the count of odd numbers so far, which is 3, minus k, which is 3 also, so it's 0. So prefix of 0 here is 0, right? So at this position we add nothing, and then when we move to this position, sorry, actually this is 1, because we remember we start from this, we start from the first position, and so that would be 1, so we count it as 1. And then we will move again here, and now we have 4. We have one subarray that has 4 odd numbers, and so also bigger or equal to k, and so 4 minus 3 for x here, that becomes 1, and so we need to add to res those of the prefixes that have 1 odd numbers, right? Because those that have 1 odd number, and so we have those that have 1 odd number, so we can start and leave those that have 1 odd numbers and get to the last one that has 4 odd numbers, so what's in between would have 3 odd numbers, right? And so that would be prefix of 1, that's just 1, so we'd add another one, and so at the end we will have our result equal to 2, which is the right solution here, right? So you get the, I hope you get the idea of this. Now let's just type this in Leetcode and make sure it passes. Okay, so I typed the exact solution that that we just discussed in the explanation. So we have the count, the total count of the result, and we have the count of odd numbers so far, and then we have the prefix that says at each, for each odd number of odd numbers, how many prefix subarrays have that count of odd numbers. And so at each position we say, okay, the current position is the end of a prefix that has count odd numbers, right? And then we check if the number is odd, we increase the count of odd numbers so far, and if we reach a count odd numbers that exceeds k, then we need to look of all the possible subarrays start that are ending at I that contains k odd numbers, and this, the value here is what we called x, right? And so we will look for all the prefix subarrays that have x odd numbers, because all those are possible start of our subarray that contains k odd numbers, and we add that to the overall count and we return it. That's pretty much all there is to it. So let's run this and submit. So let's call this A, and that's K, cool. Okay, so that solution passes Leetcode here, yeah, so that's this solution. Okay, so what's the time complexity for this solution? So you can see here that we are doing only one traversal of the array, and so the time complexity is just, so the time complexity is just O of n, right? Because we are traversing the array only once. And the space complexity here, we are using this extra map prefix that will contain at most also the number of odd numbers in the array, which can be at most n, so that's also O of n. Okay, so another way to solve this problem that is perhaps a little bit easier to understand this is to use the same idea of the prefix sum that we mentioned, where when you are looking for a sum for a certain range, you can just take the sum up until from 0 until that last index, and then just minus it with from 0 to left minus 1, right? So what we are looking for is ranges with k odd numbers, exactly, k odd numbers, exactly. So what we can do is find all ranges that have at most k odd numbers, so that have less or equal, so less or equal than k odd numbers. and then find all ranges also that have at most k minus odd numbers. So anything less or equal to k minus 1 odd numbers. And so the value that we are looking for, which is this one, let's call it ranges. So let's call them big R, or let's just call them maybe f of so we can just actually let's call the first one f of k, so at most k odd numbers, and let's call this one fk minus 1. So what we are looking for, which is, let's call this j, so j we are looking for is just f of k minus f of k minus 1, right? Because if we find all the ranges that have at most k odd numbers and all those that have k minus 1 odd numbers, what's in between is those that have exactly k odd numbers. And finding f of k and f of k minus 1 is really easy with the sliding window technique. We will just do something like this. So if we define our function that gets, let's call it f of k, so it gets at most k odd numbers, then we can start counting. So we need something to count the odd numbers, and for a sliding window technique we need the start and ending position. So let's make them both start at 0, and we need a variable to keep the result count, right? And so while we haven't reached the end of the array, we can just count the number of odd numbers. So that would mean we add 1 if the element at position j is odd, otherwise we add 0. And then we shrink the window if we exceed what we are looking for, right? So here at most k, so whenever you get a range that has more than k, we need to, so let's say here is I and here is j, right? If this range starts having more than k, we need to make I advance here, so that we can have a possibility to have less than k odd numbers. But if we have less than k numbers, at that point we need to keep expanding the sliding window, so we need to advance our j, and that's what we will be doing within this here. So but here we need to shrink when the count becomes bigger than k. We need to shrink the window so that we can have a possible window that has what we are looking for, which is at most k. So if this becomes bigger than k, that means we need to shrink the window, and that means we will need to say, so count odd, we'll need to subtract 1 if we have an odd number that we are just moving the window away from it, so we can subtract it, right? And so if this is an odd number, otherwise we do nothing, right? And then we advance our window, right? And just before incrementing j here, we need to count the range that we just found. So when we exit this loop, the count odd would be equal to k or less than k, right? And anything less or equal to k, we want to count it. So we need to include that in our range, in our result. And since we are taking anything that is less than k, so anything in that interval aj, so ij, like this, we need to get the entire interval, because anything, if this is like k or less than k, so anything in between, any interval in between would have also less than k odd numbers. So we'll need to include it in our result here. And then we can advance j. And this is just expanding the window. And at the end, once we are done, reach the end of the array, we can just return the result. And we can just use this function and return the result we are looking for. And so let's code this one and see if it passes Leetcode test cases. Okay, so I typed the what we just saw in the explanation and we just need to call it here. So this one will compute at most, so number of intervals or subarrays with at most k odd numbers, at most k odd numbers. And so we can just call it here to get the what we want, which is exactly k odd numbers, and that would be just those that have at most k odd numbers and those that have at most k minus 1 odd numbers, and anything in between has exactly k odd numbers, right? And so that's pretty much it. So let's run this. Okay, so again, I'll submit. Okay, so this solution passes. In terms of time complexity, we traverse the array only once, right? Only once for each call of f, and so overall it's 2 n, because we do 2 calls to the function f, and the function f just has one traversal to the array, and so this is just O of n in the same way as the previous function. And it's better than the previous function because here we use constant space. We use no extra space. Yeah, so that's it for this solution. Yeah, thank